share our knowledge on biochemistry. In this video, we're going to focus on the topic of lipids. So stay tuned until the end of this video, and without further ado, let's learn about the lipids now. Let's go! Unlike the other biomolecules, all lipids are not composed of the same monomers, but they do share some properties.
All lipids have carbon skeletons like other biomolecules. In addition, they do not really dissolve in water as they are nonpolar. Examples of lipids include fats, steroids, and phospholipids. Let's look at fats first. Fats are used by organisms for long-term energy storage. They are composed of 3 fatty acids attached to a glycerol molecule. Therefore, they can also be called triglycerides. The fatty acids are composed of long hydrocarbon chains depending on the structure of the fatty acids. Fats can be saturated and unsaturated.
As you can see, fatty acids are added to the glycerol by condensation or dehydration reaction. 3 fatty acid tails are added to the glycerol, so 3 water molecules are removed from these bonds. While the bonds created covalent bonds as in any condensation reaction, these are specifically called Ester Linkages. The picture on the right shows a more realistic representation of a fat molecule overall shape. If you notice, the 3 fatty acids are straight for this beta fat molecule. The fatty acids found in fats like butter and animal fat are straight. This means that there are no double bonds between the carbon atoms. Fats that have these types of fatty acids are called saturated fats. They are typically solid at room temperature as the fat molecules are packed closer together. However, if the fatty acids have at least one double bond between the carbon atoms, this causes a kink in the fatty acid tail. Fats that have these types of fatty acids are called unsaturated fats and are typically liquid at room temperature because the molecule cannot pack closely together.
Our next lipid group is steroids. They are very distinctive as they consist of 4 fused carbon rings. Steroids usually act as hormones in living organisms and include cholesterol, estrogen, and testosterone. Here are the molecular structures for those 3 steroids. While they have few different functional groups and side chains, they all possess 4 fused carbon rings.
Phospholipids will be the last lipid group we examine. Phospholipids consist of a polar head and a non-polar tail, giving the molecule a dual nature. As a result, phospholipids are amphipathic, meaning they have both an affinity for and an aversion to water. This property allows them to form membranes in cells. The head contains a phosphate, glycerol, and a polar or charged group which makes the head hydrophilic. Attached to the head are 2 nonpolar fatty acid tails. Like in fats, these fatty acids can be saturated or unsaturated. Phospholipids are very important. They form the bilayer of all membranes found in and around cell. As you can see, The bilayer is created because the hydrophilic heads have an affinity for water, while the tails form an inner layer that excludes water. With that, we have come to the end of our lesson. Hope you guys find this video helpful. Thank you for watching.
Thank you.